Let's take a look at how to apply functions a few different ways in pandas. The first two ways I want to look at are ag and transform. So these work series by series. Here I have 3 columns in a data frame. I'm going to get 3 different function applications. Ag will reduce each series to one value. Transform keeps the same shape. We'll see that when we get into some code. On the flip side, there's then map, which doesn't operate by series. In fact, it operates element by element. So each color here, if we had a 3 by 3 data frame, you'd actually get 9 function applications in Python. It can be kind of slow. Finally, there's apply, which you see a lot. Unfortunately, it is overused. The rules for apply are kind of complicated in a way I'd say is unnecessary. If it's a series, it goes element-wise. If it's a data frame, it goes by series, but there's keywords that toggle it. Generally, try to avoid apply. Use as a last resort. Let's take a look at some code here, and I'm going to jump in and just create some random seeded data. We'll start with 42 as the seed, every programmer's favorite number. And yeah, I'm just going to create 10,000 rows by 10 columns and just give, random labels to the columns here. And then I'm going to subtract 0.5 just to get some negative values in there. So that's what it looks like. Let's say we want to sum what was in this. Well, we could do df.agsum. Sum again is going to take all the values in A and reduce them to one value. Now, you can see here I could run agsum or just sum directly. There's really not that much of a difference. But where ag becomes useful is if you want to have multiple functions applied at one time. You just put them all in one ag call, and it just works. It's pretty nice. And yeah, like I mentioned, each series here gets reduced to one value. So A gives back one value. Transform is different. So transform will keep the shape of each element. Abs is a great example of this. So absolute will make a negative number positive, keep a positive number the same. Doesn't change the shape, right? So transform is going to go series by series and just apply that. Now I could also apply the same thing with map. Although map doesn't accept a string, I need to actually give it a Python function to apply. And it's going to take this and run it element-wise, right? So each and every cell gets this function applied to it. Now, if you're following along closely, you may wonder, does it matter if I do transform or map with abs? In this case, it really doesn't. You'll get the same result, except performance, right? So I mentioned that transform and ag work by series, map works by element. So let's see if we were to do some benchmarks, what this would look like. And this will, again, show you the difference between the two. A quick transform, and we'll use even a lambda function here just to have the same argument. You can see that that's the runtime there. If I just change that transform to map, I can run the same exact code. But it's going to take a lot longer. Okay, so if you're thinking about scalability and writing performant code, you really want to try and use ag or transform. They're going to work on a series at a time. Element by element map is really not that different from looping in Python, which is kind of slow. Now you could also use apply, but again, I don't want to get into the rules for apply here. I would really just use this as a last resort. Maybe in a group by, apply is kind of like looping over each group and gluing things together. But when you're not in a group by, I really don't think there's a reason to use it at all.